Good morning students. Now we will learn some of the very practical units. These units are used to find out a distance between planets to planets. There are three basic practical units or larger units because you are aware that distance between the one planet to another planet is larger one. For that, kilometer is considered as a very smaller segment. So we require some of the very larger units. The very first unit is called as astronomical unit. It is abbreviated as AU. Another one is called as a light year, represented as a LY. And third one is called as a parsec. So these three units are there. One is astronomical unit, another one is light year, and third one is a parsec. It is represented as pa because sometimes we are not using PA word because another word or another unit is there. It is called as a Pascal. But yes, parsec is there. So ideal way is that whenever you are using parsec, mention parsec in a full manner. Now going in the depth of it. So very first we are talking about AU. It is astronomical unit. It is called as a distance from center of sun to center of earth. You can just remember as it is a distance from center to center. Let's say one planet over here, let's say it is earth, its center would be there, and one another planet would be there, its center would be there. So it's called as a distance from center to center. This entire distance is called as astronomical unit. It is shown as a 1 AU. There is one measurement. 1 AU is called as a 1.496 cross 10 to the power 11 meter. Remember this term because whenever we are using astronomical units, you can see 10 to the power 11 meters. It is a larger unit compared to the kilometer. So 1 AU equals to 1.496 cross 10 to the power 11 meters. Second one, it is called as a light year, LY. Its a primitive definition is that if sun ray, or you can say ray of light, travels with velocity of light in vacuum for one full year, the distance it has traveled is called as light year. Very simple definition: sun ray or a ray of light travels with the velocity of light in a vacuum for 1 year. The distance it has traveled is called as a light year. Let's say, simplifying this term, let's say my velocity of light in a vacuum is a 3 cross 10 to the power 8 meter per second, and my time period is called as 1 year. So I can say that it would be 365, you can say, days. But basically we are not using the, whenever converting such type of units, we are not using days, so I'm converting in terms of second. So 365 days, 24 hour, 60 minutes and 60 seconds. You can say my time would be 365 multiplied by 24, 3660 seconds. This is my time, this is my velocity, so I am using that. My displacement v is equals to displacement by time. I want to utilize my displacement. It is called as a velocity into time. So my displacement velocity is equals to 3 cross 10 to the power 8 multiplied by 365, 24, 3600. So you can say that d, it is called as 9.46 cross 10 to the power 15 meters. It is nothing. It is called as a 1 light year. So 1 light year is larger compared to our astronomical unit. You can see that it is a 1.496 cross 10 to the power 11, and here your 1 light year equals to 9.46 cross 10 to the power 15 meter. You have one wide advantage of using light year is that you can get access to more 10 to the power 4, because you have astronomical unit which is only restricted to 10 to the power 11. So this is how a light year is also used to find out distance between the two planets. Third one and very important one, it is called as a parsec. So third unit, it is called as a parsec. It is giving us a one again reminder of our radian unit. And you are aware about such type of a circular figure where you have this one angle. Let's say I'm using this one value as a 1 second. Whenever your angle is a smaller one, you can say that distance is a higher one. A, B, AB is called as your arc. Let's say I'm mentioning it is as a 1 AU, and that distance between O to B or O to A, it is called as a parsec. I can remember that or give a definition. If my arc is a 1 astronomical unit and my extended or angle subtended is 1 second, my distance between two planets called as 1 parsec. Again, if my arc is 1 astronomical unit and my angle which is 1 sec, you can say that distance between the two planets is called as a 1 parsec. Let's say angle equals to arc by radius. Instead of radius, we have taken OB. So what I am just converting is that it is double implies I want to find it out my radius, which is called as OB, or you can say that OA. So my radius OA or OB is equals to arc divided by angle. My radius is one type of a distance. My arc is equals to 1 astronomical unit and my angle is 1 second. We are converting all those things, which is my distance or in terms of a radius. I can say that 1.496 cross 10 to the power 11 meters and 1 second. So first of all 1 divided by 3600, it is converted now in terms of angle. Pi divided by 180, now it is converted in the terms of a radians. Now denominator going in the numerator. So after conversion I may get that my distance is equals to 308728.6 cross 10 to the power 11. I have just kept this one divided by this one, so 10 to the power 11 meters. So roughly it will get 3.08 cross 10 to the power 16, because 1 2 3 4 and 5 meters. So my 1 parsec is equals to this much meters. So students, remember that we have a 3 units. One is called as the astronomical unit. So 1 AU equals to 1.496 cross 10 to the power 11 meters. 1 light year is equals to 9.46 10 to the power 15 meters, and 1 parsec equals to 3.08 cross 10 to the power 16 meters. So gradually you will see that powers are increasing, and it will give you the wider areas of your measurement. So whenever we will find it out distances which is larger or maybe planetary distances, we will use these 3 units, 1 astronomical unit or light year or parsec. Hope it may clear your idea about the measurement. Thank you.